Greetings and welcome to a series of lectures on intermediate algebra quadratic equations. 7.3 Additional items involving solutions to equations. So what do I mean when we're talking about additional items? Well, we already have a handful of tools that we can use to solve quadratic equations. We have factoring, we have completing the square, we have the quadratic formula. So we have quite a few tools in our arsenal to be able to solve quadratic equations. Additional items that will be helpful is looking at those tools that we have in a little different way, as well as what's called the discriminant. Now, the discriminant doesn't help us solve the equation, but it does help us recognize what solutions we should get in the end. So it will indicate the number of solutions as well as the type of solution. So what is the discriminant? Well, you've seen it. It's part of the quadratic equation. So the quadratic equation is x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. The discriminant is the b squared minus 4ac part. So how does that help us? How in the world would that help us in realizing what, or I should say how many solutions we have and what type of solutions? Because that's under the radical. Here's what we have. If the discriminant is negative, if that calculation of b squared minus 4ac is negative, then we will have two complex solutions containing I. If it is negative, which makes sense because if we have plus or minus the square root of a negative number, it is going to involve I because we have a negative square root. If it is 0, then we will have one rational solution. Why? Well, because if the square root part is 0, then we are left with negative b over 2a. That's it. No plus or minus, so there's not two solutions. It's not imaginary because there's no negative square root. And there's not two possibilities here because it's actually 0. So we will get one rational solution. If it is a positive number and a perfect square, then we will have two rational solutions. If b squared minus 4ac is a perfect square, then it will be something like, let's say it's square root of 4. Well, then it's going to be negative b plus or minus 2 all over 2a. Well, we'll have two rational solutions. And then if the number is positive but is not a perfect square, then we'll have two irrational solutions. Why? Because this part is going to be irrational. So we will have negative b plus the irrational part, negative b minus irrational part, and both of those are over 2a. Let's take an example, work with the discriminant, and figure out the number and type of solutions. X squared minus 3x minus 40 equals 0. Well, when using the quadratic equation, a will equal 1, b will equal negative 3, and c will equal a negative 40. Now I just want to look at the discriminant here, which is b squared minus 4ac. That's the only thing I want to look at here is the discriminant. B squared will be negative 3 squared minus 4 times a, which is 1, times c, which is negative 40. Negative 3 squared is 9. A negative 4 times 1 times a negative 40 is a positive 160. And 9 plus 160 is 169. Good news is it's a positive number, so we have two choices here. One, is 169 a perfect square, or is 169 not a perfect square? Well, 169 can be written as 13 squared, so it is a perfect square. Therefore, we know we have two rational solutions. We don't know what they are. We just know in the end, when we go through all of our process, we should have two rational solutions. Let's work with another example. Again, I'm only going to look at the discriminant to figure out the number and the type of the solutions. So I need to pull out the information for the discriminant. It would be A equals 2, B equals negative 3, and C equals 4. Now I'm looking for the discriminant, b squared minus 4ac. B squared is negative 3 squared minus 4 times 2 times 4. Negative 3 squared is 9. Negative 4 times 2 is 8, is a negative 8. Times 4 is a negative 32. So therefore, 9 minus 32 is negative 23. Okay? Because it's negative, because our discriminant is negative, that will let us know the number and type of solutions, which will be two complex solutions, meaning they contain I. So the determinant will tell us the number, 2, the type, complex, and it doesn't tell us what our values are. We just know what we can expect. And since it is part of the quadratic formula, and you are going to work with the quadratic formula, it's just part of the process. So once you figure out that determinant portion of the quadratic formula, you can anticipate the number and type of solutions that you'll run into in the end. Okay, let's use the determinant again to figure out the number and type of solutions we should get for this quadratic equation of 4x squared minus 12x plus 9 equals 0. All right, A equals 4, B equals negative 12, and C equals 9. I'm looking for b squared minus 4ac, our determinant. b squared minus 4ac. b squared is negative 12 squared minus 4 times a is 4, and c is 9. 12 squared, negative 12 squared is 144. And negative 4 times 4 is negative 16. Negative 16 times 9 is negative 144. Well, 144 minus 144 is 0. Because our solution, our determinant is 0, we will have one rational solution to this quadratic equation. Solution. And our actual rational solution here will be x equals negative b over 2a, which will be x equals a negative 12 over 2 times 4. A negative 12 is positive 12. 2 times 4 is 8. In other words, x equals 3/2. So I found my solution because I knew my determinant was 0. I didn't have to work out a lot of extra math. I would have had to figure it out anyway using the quadratic formula, but it simplified my work slightly. All right, one more example here, and we're going to use the determinant to figure out the type and number of solutions. All right, I am looking for a equals from x squared plus 6x equals 8. First of all, I do need to write it in standard form, so I'm kind of jumping the gun here. X squared plus 6x minus 8 equals 0. That will give me a equals 1, b equals 6, and c equals negative 8. Now I can use determinant. b squared minus 4ac will be 6 squared minus 4 times 1 times negative 8. 6 squared is 36. Negative 4 times 1 times negative 8 is positive 32. And 36 plus 32 is 68. It's a positive number, so again, our choices are, is it a perfect square or is it not a perfect square? 68 is not a perfect square, therefore we will have two irrational solutions to this quadratic equation. Okay. So again, it does not tell us what they are. It doesn't tell us the exact value of x, but it tells us what we should look for our solution. So let's use the determinant in another way. Let's figure out, we have a quadratic equation, but we're not given all the information. Here's our quadratic equation. 4x squared minus kx equals negative 9. We're not given the value for the linear term, but we want to figure out what value of k will result in one rational solution for our quadratic equation. Well, how do we use the determinant to figure that out? Our determinant, if our determinant, which is b squared minus 4ac, if that equals 0, then we'll have one rational solution. So what we're going to do is figure out what value of k forces the determinant to be 0. First things first, we need to write our 4x squared minus kx equals negative 9. We need to write our quadratic equation in standard form. 4x squared minus kx plus 9 equals 0. That means our values for our determinant, we need a, which equals 4, b equals negative k, and c equals 9. Okay. Let's plug these values into our determinant, which equals 0. Negative k squared minus 4 times, a is 4, that. C is 9. Okay. Negative k, positive k squared, sorry about that, minus, well, 4 times 4 is 16 times 9 is 144, and all of this should equal 0. We're forcing it to be one rational solution. There's 0. Therefore, now I can use my skills to solve this quadratic equation. I'm going to add 144 to each side. K squared equals positive 144. Take the square root to solve for k, because I am looking for the value of k. I have to remember on the right-hand side, it's now plus or minus the square root of 144. So k can equal plus or minus 12. And that will force our quadratic equation to have one rational solution. K could be positive 12 or k could be negative 12. Here are a few problems you can try on your own. So for the first three, go ahead and use the determinant to find the number of solutions and the type of solutions. That means either if the determinant equals 0, you'll have one rational solution. If it is a perfect positive perfect square, then it will have two rational solutions. If it is positive but not a perfect square, then it will have two irrational solutions. And if it is negative, it will have two complex solutions in containing I. Then go ahead and determine the value or values of k so that each of the following quadratic equations have exactly one rational solution. So try those on your own. See if you can follow the steps. So what if we have solutions, but we want to actually build the equations from the solutions? In fact, we want to kind of go backwards. Let's say we know that x equals 3 and x equals -2. Well, working backwards, we know that since x equals 3, we can subtract 3 from both sides, giving us x minus 3 equals 0. Likewise, x equals -2, we can add 2 to both sides, and we get x plus 2 equals 0. But again, we're working backwards, so we can reverse the zero factor property, giving us x minus 3 times x plus 2 equals 0. FOIL, multiply through, and we'll get x squared minus x squared minus x minus 6 equals 0. But keep in mind, this is actually just one quadratic equation that has the solutions of x equals 3 and x equals -2. There's actually infinitely many quadratic equations with those two solutions. What I mean by infinitely many, if we have the solution, our equation, of x squared minus x minus 6 equals 0, then any scale of this quadratic equation will also have the solutions of x equals 3 and x equals -2. Here's what I mean. Any scale means if we multiply, well, the left-hand side and the right-hand side by a, then we'll have ax squared minus ax minus 6a still equals 0. Let's pretend that a equaled 5. Then our original equation, x squared minus x minus 6 equals 0, will turn into, let's let a equal 5. That would equal 5x squared minus 5x minus 30 equals 0. And that quadratic equation also has the solutions of 3 and -2. We can multiply this, we can multiply this quadratic equation by any value, and it will have the same, except 0, will have the same type and quantity and actual solutions. So that's one way of changing the quadratic equation to have a particular look to it. The second is any power of the factors. Okay. So our factors were x minus 3 and x plus 2. If we raise those factors to any positive power, it will also have the same solutions. In this case, it will just have a different, what's called multiplicity. So that means that multiplicity R of x minus 3. That means if I have, let's say R is 2. That means I have x minus 3 times x minus 3 times x plus 2 equals 0. That means my solutions are x equals 3, x equals 3, x equals -2. The multiplicity means that I have the same value twice. Whatever power R is here, that's the multiplicity of that particular solution. Likewise, if there was a power of 3, x plus 2 all to the third power, that means that that answer has the multiplicity of 3. That means it happens 3 times. So I would have x equals negative 2, x equals negative 2, x equals negative 2. In essence, multiplicity is how many times it repeats. So if you were given x equals 3 with the multiplicity of 1, and x equals negative 2, multiplicity of 1, then your equation that would come out of that would be x minus 3 times x plus 2 equals 0. In other words, x squared minus x minus 6 equals 0. But if you're given x equals 3, multiplicity 2, and x minus 2, multiplicity 1, then your equation that comes out of there, well, x minus 3 squared, x plus 2 equals 0. And if you work this out, it's x cubed minus 4x squared minus 3x equals 18 equals 0. Oh, plus 18, sorry, equals 0 would be the equation that comes out of the two solutions with the multiplicity as 2 and 1. And again, you would have a different equation if the multiplicities were reversed. If you had x minus 3, or x equals 3 with multiplicity of 1, and x equals negative 2 with multiplicity of 2, that would look like a different equation, although the solutions still hold. Let's work with an example. Given we have t equals 5, t equals negative 5, and t equals 3, let's find the equation that has those solutions. And I'm going to work with the simplest equation, which means all of the solutions have multiplicity of 1. So if t equals 5 and t equals negative 5 and t equals 3, I'm going to set each one of those equaling 0. So let's subtract 5 from each side. That's t minus 5 equals 0. Add 5 to both sides for the second one. T plus 5 equals 0. And subtract 3 for the third one. T minus 3 equals 0. And again, I'm only going to work with multiplicity of 1. So there's 1 here, 1 here, 1 here. To find the equation, t minus 5 times t plus 5 times t minus 3 equals 0. Well, I'm going to do the first two factors. T minus 5 times t plus 5 is t squared minus 25, because those are just opposite signs. T minus 3 equals 0. Now I'm going to FOIL this. T squared times t is t cubed. T squared times negative 3 is negative 3t squared. Negative 25 times t is negative 25t. And negative 25 and a negative 3 is negative 70, or positive 75. There's my equation. Granted, there are lots of other equations that I could have found. I just used the one where each of those answers had the multiplicity of 1. Let's work through another problem similar. Given the solutions, we want to find an equation. Again, I'm going to work with the simplest equation, which is multiplicity of 1 for each of the solutions. So we have x equals negative 2/3 and x equals 4/5. There are two ways of doing this problem, so I'll show you the first way. One is, let's set each of these values to 0, or solve each of these for 0. So add 2/3 to both sides. I get x plus 2/3 equals 0. Subtract 4/5 from both sides. X minus 4/5 equals 0. Okay. I have my two factors. X plus 2/3 times x minus 4/5 will equal 0. And I can find my equation by doing FOIL here. X times x is x squared. X times negative 4/5 is negative 4/5 x. 2/3 times x is positive 2/3 x, and positive 2/3 times negative 4/5 is negative 8/15 equals 0. Only thing I need to do is find common denominator and combine my linear terms here. Looks like it will be 15, so 12/15 x plus, or negative 12/15 x over 10 plus 10/15 x minus 8/15 equals 0. All right, let's combine those. X squared minus 2/15 x minus 8/15 equals 0. Now that is certainly an equation, but it's not in standard form. Standard form is each of the coefficients and the constant term are integers. So I'm going to multiply the left-hand side and the right-hand side by 15, whatever the denominator was there. And that will give me 15x squared minus 2x minus 8 equals 0. And I'm going to say that is my equation with the solutions of negative 2/3 and positive 4/5. Again, that was one way of solving. I'm going to show you another way of solving it. Second way of solving, or finding the equation given the solutions of negative 2/3 and 4/5. What I'm going to do is I'm kind of going to jump the gun and try and force it to be in, get rid of the fractions early, right? So the first one, I'm going to multiply both sides by 3. That will give me 3x equals negative 2, fractions gone. Now I add 2 to both sides, I get 3x plus 2 equals 0. For x equals 4/5, I'm going to multiply both sides by 5, giving me 5x equals 4. Subtract 4 from both sides, 5x minus 4 equals 0. Now I have my two factors, 3x plus 2 and 5x minus 4. 3x plus 2, 5x minus 4 equals 0. And let's FOIL. 3x times 5x is 15x squared. 3x times negative 4 is negative 12x. 2 times 5x is positive 10x. And 2 times negative 4 is negative 8 equals 0. Combine like terms. 15x squared minus 2x minus 8 equals 0. We actually found the same equation, but using a different method. So use what I just showed you to find the solution, find the equations with the solutions of, and keep in mind the multiplicity in these. X equals negative 5, x equals 2 with both multiplicity of 1. X equals 1/2 with multiplicity of 2, and x equals 5 with multiplicity of 1. And then x equals 2 plus 3i, x equals 2 minus 3i with multiplicity of 1. Right. So that's it for this video lecture. Until next time, be seeing you.